Hey, I'm Olivia from Team 3486, the Techno Warriors Advanced, and today I'm going to be talking about the drivetrain from our block party robot, Lulu. So first off, we actually used 4 motors, 2 on each side, to propel ourselves and power the drivetrain. And then we used the 3-inch Tetrix wheels, the standard ones that come in the kit. We actually used 10 of these. So the exterior wheels, they are actually raised up slightly. And then we have the 3 central wheels. They're all on the same, and they stay on the ground most of the time. And then we have another wheel out here that, both exterior wheels are raised up a little bit, and then the central wheels are all stay on the same level on the ground. So one of the reasons we did this was obviously to go over the ramp obstacle. That was really important. We wanted to be able to go over that elegantly and hopefully not fall over. The drivetrain helped with that, but also center of gravity. Again, if you have a nice 1/8-inch steel plate on the bottom of your robot, or technically 4 1/8-inch steel plates on the bottom of your robot, it's going to help with your center of gravity and generally help you not fall over. Well, please note that we have fallen over twice this season, but we improved that. But center of gravity was the main thing. Again, with the going over the ramp, as opposed to last year's design, we just had the 3 wheels down here in the middle. We didn't have the exterior wheels, which wasn't really a problem. You might see our robot rocking around a little bit if you saw Pipsqueak from Ring It Up. But that really wasn't an issue because there wasn't a height element. Pipsqueak could not go up a ramp. That would be really sad to watch Pipsqueak try and go up a ramp. But Pipsqueak couldn't go up a ramp, but that wasn't in the game, so it wasn't really a requirement for Pipsqueak to go up a ramp. With there being a ramp in the game this year, we wanted to make sure that Lulu could go up a ramp easily. Okay, another reason that we did this was with the 3 wheels in the middle, and then if these 2 aren't on the ground at all times, it helps the robot spin and not hop. Turn on an axis really easily. Again, being a bigger machine, it's really important that we could be very maneuverable and move around easily on the field. So that really allowed us to be graceful in that manner. Now, our drivetrain is actually chain and gear driven, so the 3 central wheels, again, they are, these here are the 2 here. Those are actually gears, so they're geared together. But then from the motors, there's a chain looping the exterior elevated wheel and the end of the central wheel on both sides. Now, the reason we use chain here, again, Pipsqueak last year, this was an improvement. We used a gear to do this. And the reason that we didn't use gears this year is because that was really hard on the gearboxes. The way the chain is, it's actually reasonably loose. So we conserve gearboxes and don't go through those nearly as quickly. Because we actually have stall code, which if you look on our notebook, you can find that. So we don't really burn out motors, but gearboxes sometimes, those we would strip, and that was really a major improvement on conserving those. So with our gear ratio, it's geared 3:2. That way we're geared for speed. Using the 3-inch wheels with the sprockets 3:2, that actually makes us pretty much equivalent to a 1-to-1 on a 1-to-1 on Tetrix 4-inch wheels. So that's our equivalent. So on the field, we were actually one of the faster robots, which you might not necessarily expect because of our weight, but we did move really quickly, which was definite benefit considering the 2.5-minute time period of the match. One of the later improvements that we made to our robot, this was right before Worlds, this is an old steel plate. This is an old steel plate. This hole, in the back, we actually lowered it down slightly. It's still off the ground, but we lowered it down so that we wouldn't rock as much, because with the way our scoop mechanism worked, it needed to be on the ground, and as we accelerated, we were tipping just a little bit, and that was making us not picking up blocks as much as we wanted to, so we lowered this down slightly, and that really helped with that. So that was an improvement we made later on, but actually aside from that, we prototyped this drivetrain significantly and really thought about it from last year and think we wanted to change. And actually other than that, it's really stayed pretty consistent and it hasn't changed that much over the season. For the way that we support we support both sides of the wheel. That's something important that really helps, so that we have steel plate, wheel in between. That way, if both sides of the shaft are supported, it really helps the drivetrain. And then even on the exterior of that, we use the 80/20 T-slot aluminum. This is what most of our robot's made out of, as opposed to like standard Tetrix channel. Now it's slightly heavier, but it really made our drivetrain very protected, you could say. And that was really an improvement again. Okay, so if you have any questions about our drivetrain this year, anything that you think we might could help you guys with, we really like to help teams. Our whole engineering notebook is online. That should be linked below. If not, you can look us up. You can also ask us any questions below, or you can look on our notebook, and we have all about our drivetrain on the notebook as well.